Continuation of graphing ellipses. Yesterday we focused on graphing ellipses that had the center at the origin. Now we're going to introduce you when we have translations. Translation more from the parents, or when you shift up and down, left or right. So this first slide is already in your notes from yesterday. It's just the general form equations for an ellipse. The big thing to remember is your A is always going to be the bigger number. So when you look at an equation in standard form, if the A is bigger here, you're going to have a horizontal. If your A is bigger here, then you'll have a vertical. Okay? All right. So let's go on to this slide here. This is now when we have a translation. So think about circles. Circles have translations. They're not always at the center, 0, 0. They may be to the right a little bit and then up a little bit. And so what you want to be careful with is this equation right here. X minus h all squared over a squared plus y minus k all squared over b squared. When I tell my students to find the center, it's always opposite h and opposite k to find your center. Okay. Now notice that A and B could be switched around like it was yesterday, converting it from a horizontal ellipse to a vertical ellipse. So that's what I would highlight in your notes, is what I've written on in the red. This slide is in your notes. It just kind of puts everything all together in case you have a translation. Notice if you have a horizontal ellipse, your A is the greater, B is the smaller. This would be your center, HK. The distance on the major axis to a vertex to the center, this distance is A. Your other endpoint, just lost my symbol there, I think. Yeah, we'll wait for it to pop back up. The distance from the center, this endpoint here would be your B. And then this distance from the foci to the center would be your C. Same thing would happen if you made your B and then your A flip-flopped. You'll have your vertical ellipse, and then the same things apply. Here is your center. Up to that vertex is the distance A. On the major axes, minor axes, this distance would be B. And then from the foci to the center would be your C distance. All right. Let's go ahead and practice it with this example here. So we have this equation in standard form, and we want to graph it and identify the foci. So what I recommend you do is look at the denominator first. See if you're going to have a horizontal or vertical ellipse. So this is my smaller number. Which is always your B. This is your bigger number. The bigger number is always your A. So that is your A squared and your B squared. So since my smaller number is first, I'm going to have a vertical major axis line. So I'm just going to write the general standard form equation for vertical. It is x minus h all squared over b squared plus y minus k all squared over a squared equals 1. Now we're going to pick apart the center, the A, and the B in order to graph it. So, first thing, x minus h. What we said earlier is just take the opposite of that sign. So that my h then equals 1. Y plus 2 all squared. Opposite that 2 will be my k. So opposite of 2 is negative 2. So my center of my ellipse will be h comma k, which is over 1 down 2. Again, not at the origin like it was yesterday. All right, now let's find the a and the b. So my purple steriform equation, the first denominator is going to be my b squared. My second denominator is going to be my a squared. So let's go find those. Since b squared equals 4, here's my 4, then if I solve that for b, b equals 2. A squared equals 9. So when I solve that for a, I square root it. I get a equals 3. All right, let's go out and graph this ellipse. Now we have the information. When you graph it, start with your center. Your center is over 1 down 2. Then, your major axis length is going to be going vertically. We already said that. My a value is 3. So my major axis length is 2a. So 2 times a is 6. So from our center, we're going to go up 3 and down 3 to find those first set of vertices. From the center. So we'll go 3. 1, 2, 3. So there's one vertice going up. So that point is over 1, up 1. The distance from here to here is 3 units. Now I go down 3 from the center. There's my other vertice. Over 1, down 5. It also has a distance of 3 units. So here's 3, here's 3. That total length in the yellow is 6 units. All right. Minor axis length is always the b times 2b. So 2 times b, 2 times 2 is 4. So we're going to go 2 to the right from the center and 2 to the left from the center. Look at those other 2 endpoints. So there's 2 to the right, over 3, down 2. And we'll go to the left from the center. Negative 1, down 2. The distance from here to that point is your b value. Same thing here, b value. So that total green distance is 4 units. That's your minor axis length, 4 units. All right, now we're going to take those 4 blue dots, create our ellipse.
What's in the yellow?
The yellow is the distance of the a. This is a. What's your a? All right, so we create our ellipse, heading around those 4 blue dots, those 4 coordinates. It does ask us, after we graph it, to find the foci points, like what we did yesterday. The foci run along the major axes. So yesterday we used this equation, c squared equals a squared minus b squared. We need to find the c. So we substitute in our a squared, which is 9, our b squared, which is 4. We solve this for c. So 9 minus 4 is 5. We square root it. So c is 5. Square root of 5. Square root of 5 is approximately 2.2. I'm going to head back to this slide here. Right here, and right here, or right here and right here, helps you to find your foci points, highlighted in the yellow. So since we're working with the vertical, you take h comma plus c, h comma k minus c. So that's where we'll find our foci points. So we know our c. The rule says h comma k plus c and h comma k minus c, and we'll get our 2 points. So we know our c is 2.2. It's easier to graph when we don't have it as a radical. So our h from our center was over 1. Our k from our center was at negative 2, which is our k, so negative 2 plus 2.2, and 1 comma negative 2 minus 2.2. So negative 2 plus 2.2 is 0.2, and negative 2 minus 2.2 is negative 4.2. So these 2 points will be our foci. So let's go out and graph those. They should be a distance of c from the center. The distance of c is 2.2. I'll do these in red. It's a little easier to see. So we're over 1 and then up 0.2. So there's one of our foci points. Over 1, up 0.2. And then over 1, down negative 4.2. There's our other foci point. Yep.
Where did you get the negative 1, negative 2, and 3,
Negative
negative 2?
1, negative 2, and then positive 3, negative 2.
Yeah.
So we're talking this point here,
Yeah.
and this one. From the center at 1, negative 2, we have a b value that we found down here. This b value is a length of 2. So from your center, you're going to go 2 to the right and 2 to the left. That's right on that. All right. Lots of stuff going on there.
Can you scroll down?
Sure can.